Hey guys, full disclosure, I just filmed this whole video and it recorded without sound. So I'm a little bit irritated if I go a little too fast. Forgive me, make sure just a friendly reminder to pause the video and let me know if you have any questions at the end. And my favorite little guy over here, well, he's not so little anymore, is here to say hi.
Hey guys,
What's your name?
it's Anders, and I'm here with Catherine Opal.
He's off to hockey practice right now, so see you later, buddy. Bye. Okay. All right. So your goal of this lesson here is we want to use the general addition rule to calculate the probability of A or B when things are not mutually exclusive. So we've already talked about if they're mutually exclusive, you just add them together. Same thing. We still add event A together and the event B together. But if they're not mutually exclusive, what's going to happen? There's something else that has to happen. Let me slow down here. I can already tell I'm tripping over my words, okay? We also want to know how to be able to use a Venn diagram to model a chance process involving two events and then answer probability questions about that. Let's get going with that general addition rule first. So the general addition rule, again, like we said, is, hey, when you see the word or you're thinking the word or in your head while you're trying to compute probabilities, you need to add those probabilities together. The catch is if they're not mutually exclusive, so after you add them together, you think to yourself, are these two events mutually exclusive or not? If they're mutually exclusive, you're done. But if they're not mutually exclusive, meaning they can happen at the same time, you need to subtract that out. So pause the video right now and write down this formula. The probability that A in union with B, meaning or, is equal to the probability of A plus the probability of B minus the probability of A intersecting B, which means both at the same time. Pause, write down. Okay, next we have an example here so we can put that into action. Example 6, what is the relationship between educational achievement and home ownership? A random sample of 500 people who have participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. The two-way table displays the data, okay? Suppose we chose a member of the sample at random. Find the probability that the member, and we're going to figure it out. Now, real quick thing. Two-way tables, sometimes you are not given the totals for the rows or the columns, as well as the table total. I always put that in while you're doing your work if it's not given, because you're going to need it. Second, how do you figure out basic probability? Basic probability, so probability of success is equal to the number of successes over the total outcomes. And I want to be clear that a success is not always a good thing. What's the probability that you'll get struck by lightning? Not to be morbid or anything, but what's the probability you'll get struck by lightning? In this case, the success would be the probability of being struck by lightning, okay? So I'm just saying that we call it a success. It's not always a success, like it's a win, but it's just what we're looking for. Okay, back to the problem. So suppose we chose a member at random. What's the probability they're a high school graduate? Well, total outcomes. If we have, how many people in the hat? We have 500 total people in the hat, right? We mix it up. Oh, I want a color code. Not good. We mix the hat up. Out of the 500, what's the probability that they are a high school grad? Well, high school graduate is right here, and there's 310 total of them. When I divide 310 divided by 500, I get 0.62. Okay. Next question. What's the probability that they're a high school graduate and owns a own home? So that is that intersection. That's when it both happens at the same time. So I have 500 people in a hat. I shake it up. I pull one name out. What's the probability that they're a high school graduate as well as owns their own home? So out of the 500, there are 221 who are high school graduates and also own their own home. So 221 divided by 500, that gives us 0.442. All right, guys, let's keep going. We're doing well. What's the probability they're a high school graduate or owns their own home? So we see that or. We got that or, you guys. We got that or. So we are going to use the general addition rule. Whenever we see or, we're going to add up the probability that they're a high school graduate, plus the probability that we own our own home. And then we ask ourselves that important question, can it happen at the same time? And if it can, we subtract. And we'll talk about why. So that is that rule right here. So take a second and write that down. Okay, so we already know the probability that they're a high school graduate. That is 310. Oops, I thought I had it written down. Sorry about that. 310 out of 500. What about the probability that they own their own home? So out of 500, how many own their own home? So let's just quick look at that. Out of all the people that own their own home, there's 340 that own their own home. So let's look at this number right here. So 310 people. That includes everyone who owns a home, their own home, and does not own their own home. Then we have homeowners. Homeowners are 340. So this 340 includes everyone who's a high school graduate and not a high school graduate. Hopefully what you're noticing is this 221 was included in both that column and that row. And that's why we need to subtract out the probability of both of them happening, being a high school graduate and a homeowner. Minus 221 out of 500. I like to keep it in fractions. They all have the same denominator, so you just keep the denominator the same. You add up those numerators, so 310 plus 340 minus 221 divided by 500. I apologize if you can hear my family leaving for hockey right now. That gives us 0.858. And I just want to give a friendly reminder to everyone in my household that I am making a video right now, so please be quiet. Thank you. Okay, next. We have our Venn diagrams, okay? Our Venn diagrams. So a couple things. Here is a Venn diagram. Hopefully that is familiar to you. I'm going to teach you how to use a Venn diagram to answer probability questions. But the Venn diagrams are when two events are happening. So for example, we could have event A, and let's say that's everyone who owns cats, right? So I'll just put a C here. And then event B could be everyone who owns dogs. Now I could, if you could envision, if you guys are all in class together, I could say, hey, raise your hand if you own a cat or a dog. Okay, so you raise your hand if you own a cat or a dog. Now, some of you who are raising your hand, think about it right now. Would you be raising your hand? Do you own a cat or a dog? And you raise your hand. There are going to be a fair amount of you that own both. And that is the intersection right there. Okay. Now, if I say raise your hand if you own a cat or a dog, and I would count up all of the hands, right? This part right here is going to be everyone who owns a cat. This part here is everyone who owns a cat or a dog, and a dog as well, both. And then this part right here is everyone who just owns a dog. So if I say, do you own a cat or a dog? I'm going to get a bunch of you who raise your hands. Some of you are going to own both. Some of you own a cat and some of you own a dog. So A in union of B is A or B. That's what that means, okay? And it also includes that both there. Again, I have that general addition rule for you. And let's get started with making our own Venn diagram. And we'll talk more about this in class together. According to the National Center for Health Statistics, in December of 2008, 78% of U.S. households had a traditional landline telephone, 80% of households had cell phones, and 60% had both. Suppose we randomly selected a household in December of 2008. So you can imagine everyone's in this big pot. Shake the hat up. We randomly select a household, okay? Construct a Venn diagram to represent the outcome of this chance process. Venn diagrams are very useful in AP Stats. Oops, forgive me for having that over there. And forgive me for also having this here. I'm going to get rid of that. Spoiler alert. Okay, so we're going to draw two circles and we're going to label what's going on. We have the traditional landline over here and the cell phones over here. Now, when we're filling this Venn diagram out, there are 3 steps that I encourage you to follow to always get it right. Number 1, always fill in the both. So this is that middle section right here. What percent of people owned a traditional landline as well as a cell phone? And we know that that is 60% right here. Okay, Next, we say use subtraction to fill in the rest. Well, what do I mean by that? I know that this circle right here, and forgive me, it's not perfect because I'm using my mouse. This circle equals the people who own a traditional landline. And we know that 78% of them, right? 78% of them right here own a traditional landline. So this circle has to represent 78%, but 60% is already in the circle. That's the people who own both, but we also have people that only own the traditional landline. So we have 78 minus 60, okay, right? And that's going to give us 18%. Okay, I had to pause it for a second. We have real life going on in our house. We just left for hockey. All right, we're all good now. Let's get going here. Now, we have the cell phone group, you guys. That's this circle right here. So if I'm repeating myself at all, I apologize. I don't think I am, but just in case. Okay, we have the cell phone group. We know that 80% of people have cell phones. So this whole circle has to represent 80%. Again, we're using step 2 subtraction to fill in the rest. This whole circle represents 80%, but 60% are already in here. So we have this group right here. These are people that only own a cell phone. 80 minus 60, that gives us 20%. So 60 plus 20, this whole circle is 80. 18 plus 60, this whole circle is 78. Well, then we have people that own neither. That's everyone out here. So what did I put? I said 100 minus the inside, that gives us the neither. So we take 18 plus 60, which is 78, plus 20, which is 98. 100 minus that, that gives us 2%. 2% own neither. Okay, now we're on to part B. Let's use this Venn diagram to answer some probability questions. Find the probability that the household has at least one of the 2 types of phones. Okay, at least one is something you need to get down right away. Whenever you see the word at least one, think about it in terms of the probability, think about it in terms as 1 minus the probability of none. If you have that down, you can't go wrong, okay? 1 minus the probability of none. If I do 1 minus the probability of none, well, neither is 2%. So I would just do 1 minus 0.02 because technically when we think about probability, we think of it as a proportion, as a decimal. When we're calculating it, we don't always change it to a percent in AP stats. We leave it as decimals. I left it as percentages because that's what it gave us in the problem. But typically we're going to have decimals. So I just moved this 2% as a decimal. I just said 1 minus 0.02 because our whole sample space adds up to 1 or 100%, right? So 1 minus 0.02, that gives us 0.98, which is 98%. Again, at least 1 minus the probability of none. Big learning there. But I also want to talk about it in terms of the addition rule because how we use this Venn diagram, they could have rephrased part B. At least 1 means I could own the traditional landline, that's at least 1. Or I could own the cell phone, that's at least 1. Or owning both is still at least 1. So I want you to think of it in terms of or as well. In this case, the probability of at least 1 is equal to the probability of a traditional landline or a cell phone, okay? So if they would have rephrased it, instead of saying at least 1, they could have said, what's the probability people own a traditional landline or a cell phone? They could have phrased it this way. If they phrase it that way, there are 2 strategies for you guys, okay? 2 strategies. The probability of a traditional landline or a cell phone is equal to the probability of the traditional landline in union with the cell phone. So strategy 1 would be using the Venn diagram, okay? If we use the Venn diagram, then that would be that union. That would be adding up each part, like I said up here, okay? And union is each part. Whoops. Okay. So I would add up 18 plus 60 plus 20, that's at least 1, and that gives us 98%. Or strategy 2 is don't use the Venn diagram and know that when we see the word or, we could use the addition rule. But we don't want to use the Venn diagram necessarily if we do use the addition rule. Okay, so this is strategy 2. Then what we're going to use is the probability of the traditional landline plus the probability of a cell phone minus the intersection. So this means that, again, do not use the Venn diagram. You can, but in my experience as a teacher, there are lots of mistakes that happen if people use the Venn diagram when using the addition rule. Use the information they gave you. We know for the addition rule, so the traditional landline or the cell phone minus both. They give you this information up here. 78% of people use the traditional landline. It's right there. Cell phones. 80% had cell phones. That's right there. Minus both. They give it to us up here again, 60%. And that gives us 98%. Okay. What should we have learned? Hey, if they would have phrased at least one as the probability of a traditional landline or a cell phone, you either use the Venn diagram and add each part, or you don't use the Venn diagram and you use the statistics they give you up here and you add the two together and subtract out the both because they're not mutually exclusive. You can have both, or you can have both at the same time. Okay, part C says find the probability the household had a cell phone only. A cell phone only is right here at 20%. Find the probability of having neither landline nor cell phone. That's out here, this blue part, that's 2%. And the only work that has to be shown on this when you do these types of problems is the Venn diagram. And then if you would add them up together, you need to show that work as well. All right, guys, I have one more up here. I'm gonna have you try it on your own. I'll speed through the explanation at the end. If you feel comfortable, you can stop right now. But if you want one more example just to practice, I want you to go ahead and just pause the video and try this problem. And like I said, I will speed through this just to go through the right answers with a quick explanation if you need it. So pause now. I'm going to show you that I'm going to do the same. I'm going to write out the Venn diagram, the answers, and then I'll just quickly explain if you need it. Okay, so I have my Venn diagram here. We know that 66% are left-handers, 51% are both. So I do 66 minus 51 to give just the people who are left-handers. 15% are successful with their left hand, right? And then I have 82 are right-handers, are good with their right hand. 51 is both. 82 minus 51 is 31. I add these three pieces up, subtract from 100. That gives me 3% are good with neither. What percent of these workers could not operate the switch with either hand? That's that 3%. What is the probability that an engineer was successful with their left hand, but not the right? So that's just that area right here. That's 15%. And then what is the probability that an engineer was successful with their right hand, but not their left? That's 31%. All right, you guys, we did it. We made it. I made it. I made a video without noise, without volume, but this one's okay. So we're good. Thanks for hanging in there with me, and make sure you ask any questions on office hours or class if you do have any questions. Thanks, guys. Take care.